This week in science, we're going to be learning about gravity. Can anybody tell me, well, I want you to talk with your partners and tell me what you know about gravity. Okay? Take a few minutes to talk with your partners. What is gravity? Jeffrey, why don't you join one of these groups? Okay? Since your partner's gone. Okay, talk with your group now, Jeffrey, and see if you guys can determine what.
I'm gonna get confused. It's
Kira, can you tell me what gravity is?
it pulls you down.
Okay, very good. It pulls you down. Eli?
Gravity's a pulling force that keeps things on the ground.
Keeps you on the ground, right?
But
Okay.
it's a push.
Now, have you ever noticed how an object that is put into the air, does it stay in the air? What happens to it?
It falls.
It always comes back down, right?
Yeah.
What goes up must come down.
Mhm.
What we're going to do today, well, we're going to do an experiment today. I'm going to have to get, all of you guys are going to have to get out your science books. Okay? It is going to be a loud experiment. Just one time. Just one time it's going to be loud.
Don't worry.
Okay? After the experiment, I have handed you guys 2 pieces of paper. Okay? One of them tells you the steps that we're going to do, and the other one is the paper where you can write down the steps, okay? So I'm going to tell you what we're going to do. On this paper, the questions that you're going to answer is, what do you want to know about gravity? Why do you want to know it? This isn't something you have to fill out now, but if there's anything that you don't know about gravity that you want to know, write it down. And then when we're done, you're going to do some research. You guys will read your science weeklies this week that talk about gravity. You will read those, and these will help you to find the answers to this experiment today. Because what you're going to do is I want you guys to guess, or hypothesize, not guess. What we're going to do with our books is you're going to take one of these pieces of paper. Let me see your book, please. You're going to take this paper, you're going to sit it on top of your book, and at the same time, not until I tell you to, you're going to drop your book onto the floor. Okay? So that is what we are doing. That is the first experiment we're doing today. What I want you to know, what I want you guys to think about, and I want you to write down, is what do you think is going to happen? Do you think that the paper and the book are going to hit the ground at the same time? Do you think one's going to hit before the other? That's what I want you to write down. Take a minute right now on the hypotheses, form a hypotheses. I want you to predict what you think is going to happen. Okay? I'll give you just a few minutes to write that down. What you think is going to happen and why. On this paper.
Better put it down on the paper.
What?
Better put it down on the paper.
It says, number 3,
Oh.
it says form a hypothesis. My hypothesis is, I think this because. It's right there on this paper. Does everybody see that?
Yeah.
Write it down. What you think is going to happen and why. Yes.
What do we do with the predict part? Because isn't hypothesis and predicting the same thing?
Yeah.
Just write it in the predict part. I predict. What do you predict is going to happen? Yes.
What
Nate?
if we already put it in the
It's fine. It's fine. Everybody got that done? Okay, just write down right here. What do you think is going to happen when you drop these at the same time? Do you think they're going to hit at the same time? So put that down. Which one do you think is going to hit first? And then why do you think that? Okay? That's all you gotta do. You don't stand there. Everybody got their hypothesis done? Almost?
Yes.
Raise your hand when you're finished. We'll do it that way. That way I know when everybody's done. Okay. Why? Oh, everything has gravity. Okay. Okay. You can finish that later. Okay, everybody stand up. Find a space. To yourself. Stand over here if you want to. I want to hear some ideas. I want to hear some of your ideas. What you think's gonna happen. Aaron?
I think one object will hit the floor before another object.
Which one?
The book.
Why?
Because it's heavier than the paper.
Okay. Shaylee?
I think the book is going to hit the ground first, and the paper's going to be like floating through the air and then hit the floor.
Okay. Any other ideas? Eli?
Oh.
Huh?
Never mind.
Okay. All right, are we ready? Hold your books in front of you.
Just hope this doesn't hit my toes.
Where's your paper?
Oh, wait.
You need your paper. Everybody's got their paper lined up on their book, right?
Yes. Yeah.
Not over the edge. It's got to be on the book. Okay? All right, are we ready?
Yes.
Yeah.
1, 2, 3, drop.
What?
What happened?
Mine
With most of yours.
They all hit it at the same time.
They hit at the same time. The paper didn't float away, did it?
No.
Your guys' your paper wasn't completely on your book. Can anybody tell me why that is? Go ahead and pick them up.
That was funny.
That was fun.
I don't mind
It stayed.
It did. It stayed.
Yeah.
Aaron, can you tell me why? Why did gravity, but why did the paper not move? Eli?
The paper did not go down as we thought it was because as it's sitting on the book, and once we drop the book, it wants to stay with the book.
The force.
Yeah, the force.
Yes.
It wants to stay with the book.
So do you know why the paper needs to be just a little bit smaller than the book? The paper wasn't bigger than the book, was it?
No.
Any ideas why? Jeffrey?
Because there's a magnetic pole.
Not a magnetic pole. But if the paper was bigger than the book, like, okay, say the paper hangs off the side of the book. What do you think is going to happen?
It's going
It's
to
gonna
fly away.
It's going to fly away. They're air currents. The air current is what keeps this paper from dropping at the same speed as the book. So grab 2 things out of your desk, whether it be a pencil, an eraser, 2 different objects. We're going to test this out. Do you guys think that the force of gravity is impacted by weight?
Yeah.
Why?
Because the more heavier it is,
The heavier it is.
but the more gravity pulls on it, the faster it falls. Well, the more mass it has.
Ready?
Yeah.
Did they hit at the same time?
Yeah.
So you still think that?
No.
It doesn't matter. The weight of the object does not matter when it comes to gravity. Everything will hit at the same time. Go ahead, test it. Test it. It can't be paper.
It can't be.
It can't be paper unless it's like a pad of sticky notes or something like that. Then it can be paper.
What about this?
But if you have just a regular piece of paper, the air current's going to grab it and it's going to float.
So like a bookmark, please. Because I did.
You can try it.
See? Hold on. Mine will.
No, not on top of each other, side by side.
Okay, dude, don't do
And drop it. Does everything work the same?
Yeah.
Okay, stop for a minute. What's happening?
They're all falling at the same time. Little gravity.
Shaylee?
The gravity is like pulling it down and bringing it down to the ground. So
Right, and it's hitting at the same time. There is no matter what the weight, gravity's gonna pull everything down in the same way. Everything. If you were to jump off a toy and your little brother was to do it with you at the same time, you may weigh more than him, but you're both gonna hit at the same time. Right? Yes.
I never thought that.
How come like when if you jump off of the diving board at the pool, the heavier person makes a bigger splash? How come that's different than when they hit at the same time?
Go ahead.
Force is affected by speed. Got that? Okay.
That's just, a bigger object's gonna make a bigger commotion. I mean, it's just like if you were to drop one heavy thing and one light thing on the ground, like in dirt or something like that, one's gonna make a bigger impression than the other, but they're gonna hit at the same time. Okay, that has nothing to do with gravity.
Speed or weight will affect the impact.
Okay. So, do you think no matter what you choose, this is gonna happen? Everything's gonna hit at the same time?
No.
Yeah.
No. Yeah.
Yeah, if you use paper and a pencil, it won't.
Right, because why?
Because the paper floats.
The air currents,
Yeah.
because the paper's not
The
heavy
air
enough
currents-
to just drop straight down.
The air current. What if you were to hold one this way and the other one higher?
Well, then they're not.
Hit at the same time.
Try it. Why didn't they hit at the same time?
Because they weren't in the same.
What if it was like this?
Shh.
They weren't even.
They weren't even. You didn't drop them at the same height. If you drop one thing higher and one thing lower, the one thing that's lower is going to hit first
Yes.
because it doesn't have as far to go.
Yeah.
Okay, does that make sense?
Yes.
Yes, Shaylee.
If you blow a balloon up and it has air, how come it floats a little bit and if you like catch it and bring it down to the ground, will that still be gravity sort of?
If what?
Like if you blow a balloon up and you throw it up in the air, it like stays in the air for a little bit, and if you leave it alone for a little bit, it would.
Yeah, that's gravity because it's still being pulled down to the ground. When it goes, anything that goes up, it may take a while, but it has to come down unless it gets stuck in a tree. But if it goes up, gravity says that what goes up must come down.
Yes.
Jeffrey,
What if you drop something like this?
you already did.
No, like if it's like that. Like,
I'm gonna do it real quick and find out. It shouldn't matter. It doesn't matter. It'll shut it.
It will.
Yes, Jada.
Still,
So
like,
why-
when you like fill a balloon with helium, it just stays up there, like at least for 2 or 3 days.
Right. Helium will stay up because it's a gas.
It's lighter than the oxygen around it.
Yeah.
You see,
But
helium
eventually-
is lighter.
It will deflate and come down.
Yeah.
Right?
That's what I was gonna ask.
Yes, yes, yes. And these are good questions. But the moral of it is everything that goes up must come down. That is what we know. So after doing all of this, you've drawn your conclusions on your papers. I want you to write. You can come up with your own experiments. There's a place on here. Where's that paper go? That you can have your own materials. Right here. Test your hypothesis. Okay? We already did, but you can come up with other things that you have tried, like your marker and your eraser, or any two objects that you want, whether they weigh the same or don't. And you can test them to make sure that everything comes out the same. So what we're going to do after you guys are going to have some time to fill this out. And you have the back side too. Who wants to know, write down your different observations. Draw your conclusions. What did you learn? Was your hypothesis correct? And what questions do you have now? If you have any questions, I want you to write them. What we're going to do now is we're going to read the Science Weekly magazine. And you can do this in partners. So and this will answer any questions, some of the questions that you might have, and it will better explain why gravity, or how gravity works. Why this experiment work the way that it did. Yes, Jaden.
Well, this paper again.
You will need to turn that in. And that doesn't necessarily mean there's any right or wrong answers. In a hypothesis, is there a right or wrong answer? No. It's what you... Okay, the lesson that I taught was an experiment in science, and this reflection is supposed to be over student engagement. The way I planned for student engagement was I was going to have them up, I was going to have them moving, I was going to have them doing the experiment for themselves. I talked with my teacher, and we decided that doing the lesson, having them stand up and actually participate in the lesson and experiment for themselves was going to be the best way. I also had them, after they did the lesson, or after they did the experiment that I had chosen, I had them pick some objects out of their desk that they could drop, because we did the lesson on gravity. So I figured having them do it themselves would really involve them and get them active in it and make them want to do it. So after we did the initial dropping of the book and the paper, and we discussed this, then I had them choose their own objects, which I gave them a few minutes to try multiple different objects. So they were able to do this, and they really seemed to enjoy doing this. I really don't think that I had any disengagement. There were a few that, we had to adjust what they were using, and I had to explain different strategies to use it. But they were all really actively engaged in it, and they really seemed to enjoy it. I had some of them use highlighters and books, and then I had some of them tried it with a flat piece of paper and a book. And of course with gravity that doesn't work because of the air currents. So once, they had plenty of questions, and once I explained to them that it wasn't going to work because of the air currents, that they had to do something else, I told them that they could use wadded up paper. I think a few students may have tried that, but they were able to observe the fact that no matter what they used, it was going to hit the ground at the same time. I really don't think there's anything that I would have changed. I guess if I was going to change something, I could have already had items picked out for them. Because if I would have had the items already chosen for them and set out for them, then they wouldn't have had the opportunity. I mean, there wouldn't have been no distractions. There would have been no trying to find what to use, or, they could have all tried the same things. But I felt that having them pick their own things, it gave them each their own chance to try different items and see how different items worked, whether it be the same thing that another student used or whether it was something that they used on their own. So I felt that the lesson went really well. They really seemed to enjoy it. They all seemed to be involved. I had plenty of questions asking me, why did this fall faster than this? And like I said, if it was a plain piece of paper, then it was because of the air currents. But anything else would have fallen and hit at the same time. And they discovered this. And I kept them involved because I also had them write on their worksheet what they used. I had them write each specific material that they used. I had them try 2 experiments aside from the book and the paper that we did as a whole class. I had them do 2 other ones to test the theory, to test their hypothesis. And then I had them write it on a piece of paper. I had them write down what they used, what they observed, so what happened when they dropped them both at the same time. I also had some try to hold them at two different heights. And so, of course, one would fall faster than the other. So then they asked me why. So then I just told them that they had to hold them at the same height, which I guess in another lesson I could make sure that I explain that well. Everything has to be held at the same height in order for it to drop at the same time. But like I said, everything went really well. The students really seemed to enjoy the activity. There really was not much disengagement aside from trying to find different things to use. But that was kind of expected. So